Hello viewers, in today's session we are going to discuss an important type of indefinite integral in which the integrand is of this form, that is 1 over x raised to 4 plus lambda x square plus 1. So here the integrand is of the form where the numerator is 1 and the denominator is a biquadratic function, that is x raised to 4 plus lambda x square plus 1, where lambda belongs to the set of real numbers, right? So here we'll see whenever we come across with integrands of this type, that is here in the given problem we have to integrate this function, that is dx over x raised to 4 plus 6x square plus 1. So this expression is of this form where lambda is equal to 6, which belongs to the set of real numbers. So in this class we'll see how we can solve these kind of indefinite integrals using the method of substitution, right? So let us first see some important results which we are going to use while solving this type of indefinite integral. So while solving this indefinite integral, we'll make use of these two important identities, that is a minus b whole square and a plus b whole square, right? So let us take this expression, that is x minus 1 over x whole square. So applying this identity to this one, we'll get x square plus 1 over x square and minus 2. Now we can take this negative 2 to this side, so we have x minus 1 over x whole square plus 2, and this is equal to x square plus 1 over x square. And similarly, if we consider x plus 1 over x square, then applying this identity, a plus b whole square will get x square plus 1 over x square plus 2, and taking this 2 to the left hand side, we can write x plus 1 over x square minus 2 is equal to x square plus 1 over x square, right? So these two important expressions we are going to use while integrating this function. And one more important result which we are going to use here is the integral, that is dx over x square plus a square. So here we have 1 over a tan inverse x over a. So this integral is going to be very significant when we integrate this function, that is 1 over x raised to 4 plus 6x square plus 1. So to summarize here, these three important results are going to be used in solving this integral. So let us take this integral as I. So now let us divide the numerator and denominator by x square. So now this integral becomes 1 over x square, and here we have x square plus 6, and here we have 1 over x square, right? So what we have done here, we have divided the numerator and denominator by x square. So now we can write 1 over x square, and here we can combine these two terms together. So we have x square plus 1 over x square, and here we have plus 6, right? So now here one important thing we are going to do is that we are multiplying 1 over x square by 2, and here we are dividing this integral by 2, right? So this 2 and this 2 are going to be cancelled, so there is no harm in multiplying 1 over x square by 2, and dividing here by 2. So whenever we have to solve these type of indefinite integrals, so the first step is to divide the numerator and denominator by x square. So now the purpose of dividing the numerator and denominator by x square and then multiplying this term 1 over x square by 2 and dividing by 2 is that this quantity, that is 2 over x square, it can be written as 1 plus 1 over x square and minus 1 minus 1 over x square, right? So now we are going to represent, or we are going to express this quantity 2 over x square as a difference of these two terms. So 2 over x square can be written as 1 plus 1 over x square minus 1 minus 1 over x square, because when we simplify this expression, then this one and this one is going to be cancelled, and 1 over x square plus 1 over x square will give us 2 over x square, right? So now we can write this integral as half, and then 2 over x square can be written as 1 plus 1 over x square and minus 1 minus 1 over x square divided by the denominator, that is x square plus 1 over x square plus 6 dx, right? So whenever we have to integrate functions of this type, the first step is to divide the numerator and denominator by x square, and then we have to multiply 1 over x square by 2 and divide by 2, and then we express 2 over x square like this, that is 2 over x square is equal to 1 plus 1 over x square minus 1 minus 1 over x square. So now the next step is to split this integral as a difference of two integrals, right? So here we'll split this integral at this negative sign, that is we'll write I is equal to half, then we have 1 plus 1 over x square, and here we have dx, in the denominator we have x square plus 1 over x square, and here we have plus 6. So this is the first integral, and the second integral is half, and then we have 1 minus 1 over x square dx, and then we have x square plus 1 over x square plus 6, right? So what we have done here, we have written, or we have expressed this integral I as a difference of two integrals, right? So the first one is half, then we have 1 plus 1 over x square dx and the denominator, then we have half and 1 minus 1 over x square dx and the denominator, right? So let us now call this integral as I1. So here we can write half I1, and here this integral as I2, and we can now write I is equal to half, then we have I1 minus I2. So let us separately calculate I1 and I2. So now to solve I1 and I2, will make use of the method of substitution. So here we have I1. So let us substitute U is equal to x minus 1 over x, right? So when we take U is equal to x minus 1 over x, and if we differentiate both sides with respect to x, then we have du over dx. The derivative of x is 1, and the derivative of 1 over x is minus 1 over x square, that is 1 plus 1 over x square, right? So du is now equal to 1 plus 1 over x square, and here we have dx, right? So for this quantity, we can simply write du, and in the denominator we have x square plus 1 over x square. So we can now use this expression, that is x minus 1 over x square plus 2 is equal to x square plus 1 over x square, right? Because here we are taking u is equal to x minus 1 over x, so we'll now make use of this expression to express x square plus 1 over x square in terms of u. So now here taking x minus 1 over x as u, we can write u square plus 2 is equal to x square plus 1 over x square. So now our integral I1, it takes the form, here we have du, and then in the denominator we can write u square plus 2 plus 6, that is equal to integral du, and this is u square plus 8. So we can now write du, and here we have u square plus 2 root 2 square, right? So now this integral I1, it takes this form, that is integral dx over x square plus a square. Here the variable is u, and the value of a is equal to 2 root 2. So the value of I1 is now equal to 1 over A. A is 2 root 2, and here we have tan inverse x over A. For x we have u, and for A we have 2 root 2. So now replacing u by x minus 1 over x, or x square minus 1 over x, the value of I1 is 1 over 2 root 2, and here we have tan inverse x square minus 1 over 2x times square root of 2, right? So this is the value of I1. So now let us calculate the value of I2. Now here we have 1 minus 1 over x square dx in the numerator. So let us substitute here v is equal to x plus 1 over x. So if we differentiate v with respect to x, we have dv over dx is equal to 1, and the derivative of 1 over x is minus 1 over x square. So from here we can write dv is equal to 1 minus 1 over x square and dx, right? And when we have v is equal to x plus 1 over x, we can make use of this result, that is x plus 1 over x is v. So here we have v square minus 2 is equal to x square plus 1 over x square. So in this case, x square plus 1 over x square can be replaced by v square minus 2. So now I2 takes the form in terms of v, as here we have dv simply for 1 minus 1 over x square dx, and in the denominator we can write v square minus 2 plus 6. So let us simplify it. So we have dv, and here we have v square plus 4. That is 6 minus 2 is 4. So here we have dv and v square plus 2 square. So again, this integral I2 is also of this form, that is integral dx over x square plus a square. The value of a is 2, right? So the value of this integral is now equal to 1 over a is 2, and we have tan inverse v over 2, right? Now let us replace v by x plus 1 over x, that is simply x square plus 1 over x. So here we have half, and tan inverse x square plus 1 over 2x, right? So the value of the integral I2 is half tan inverse x square plus 1 over 2x, right? So now we have obtained the values of I1 and I2, and here we can also take the constant of integration as C1 and C2, which can be added in the final step to get another constant of integration, that is C. So here we are not going to take C1 and C2. We'll finally write one constant of integration as C. So now substituting the values of I1 and I2 in this expression, we have now this result. And here we can now write the final constant of integration, that is C. So now I can further be written as we can take half common. So we can write 1 over 4 multiplying half and half, so we have 1 over 4, and here we have 1 over square root of 2 tan inverse x square minus 1 over 2x root 2, and here we have simply tan inverse x square plus 1 over 2x, and c is the constant of integration. So viewers, the value of this integral is given by this expression, right? And here we have seen that we can easily solve these kind of indefinite integrals by using the application of these three results along with the method of integration by substitution. Hello viewers, in today's session we are going to discuss another important form of indefinite integrals, and in this session we are going to discuss indefinite integrals of this type where the integrand is of the form, that is x square plus 1 divided by x raised to 4 plus lambda x square plus 1 dx, where lambda belongs to the set of real numbers, right? So here in this class we are going to solve an example related to this form of the indefinite integral, right? So here we can see that the integrand, it has a numerator and denominator. The numerator is a quadratic function of the form x square plus 1, and here also we have x square plus 1, and the denominator is a biquadratic function that is of the form x raised to 4, here the degree is 4, plus lambda x square plus 1, and here we have x raised to 4 minus 8x square plus 1. And if we compare these two denominators, we can see that the value of lambda is equal to minus 8, and this is clearly it belongs to the set of real numbers. So here we'll see how we can solve these type of indefinite integrals, right? So let us see how we can find out the value of this indefinite integral. So let us call this integral as I, right? Now the first step to solve these kind of indefinite integrals is to divide the numerator and denominator by x square, right? So we have I is equal to x square plus 1 divided by x square, and here we have x raised to 4 minus 8x square plus 1 divided by x square, and here we have dx. So now the this term, that is x square plus 1 over x square, it can be written as 1 plus 1 over x square, and here we have dx. And now if we take this x square to the denominator of these three terms, we'll get x square, then we have minus 8, and then we have 1 over x square, right? So now this integral I can be written as 1 plus 1 over x square dx, and in the denominator we can collect these two terms, that is x square plus 1 over x square, and here we have minus 8, right? So the first step to solve these kind of indefinite integrals is to divide the numerator and the denominator by x square and get the form of the integral I like this. So now the second step is to make use of the method of substitution, right? So here we'll take a variable t such that this variable t is a function of x, such that the derivative of t with respect to x gives us 1 plus 1 over x square, right? So in these type of integrands, we make use of this substitution, which is quite common, that is t is equal to x minus 1 over x. So here we assume this substitution, that is t is equal to x minus 1 over x, because when we find out the derivative of t with respect to x, then here we have the derivative of x as 1, and the derivative of 1 over x is minus 1 over x square, and this becomes 1 plus 1 over x square. So now a dt can be written as 1 plus 1 over x square, and here we have dx. So now we can replace this quantity with the dt, right? So this is the appropriate substitution here. So now this integral I is equal to integral, and here we have dt, and now let us take care of the denominator. Now in the denominator we have x square plus 1 over x square. So what we will do, we'll take the square of both sides. So here we have t square, and here we have x minus 1 over x square, and here we'll make use of the identity, that is a minus b square, that is a square minus 2ab plus b square. So here t square is now equal to x square, then we have minus 2 ab, so here we have x and 1 over x, and here we have 1 over x square. So this x and this x get cancelled, so we are now left with here we have x square and minus 2, because x and x get cancelled, and here we have 1 over x square. Now taking minus 2 to the left hand side, we can now write t square plus 2 is equal to x square plus 1 over x square. So now in the denominator we can replace x square plus 1 over x square in terms of t, and this is equal to t square plus 2. So here we'll write t square plus 2, and here we have minus 8. So now this integral takes the simple form, that is dt, and here we have t square, and 2 minus 8 is minus 6, right? So now we can rewrite this integral as dt. Here we have t square, and 6 can be written as square of square root of 6, right? And now this is a standard form in indefinite integrals. So now we can easily find out the indefinite integral of this expression, because here we have a direct result, that is integral dx over say x square minus a square, and this is equal to 1 over 2a, and we have the natural log of we have here absolute value of x minus a, and here we have x plus a, right? And here the variable is t. So now we can write the value of integral I as 1 over 2 times square root of 6, because here the value of a is square root of 6, and here we have a log of x minus a, that is t minus square root of 6, and here we have t plus square root of 6, right? And c is the constant of integration. So now let us replace this t by x minus 1 over x, because in the beginning we have assumed that t is equal to x minus 1 over x. So we have I is equal to 1 over 2 times square root of 6, and then we have log. Here t is x minus 1 over x. Here we have minus root 6, and in the denominator we have x minus 1 over x plus square root of 6, and c is the constant of integration. Now simplifying the numerator and denominator, we can now write I is equal to 1 over 2 times square root of 6, and here we have log of x square, and here we have minus 1, and then we have minus x root 6 divided by x, and then here we have x square minus 1, and here we have plus x root 6 over x, right? And now we can rewrite it as 1 over 2 times square root of 6, and we have log, and this is here x and x get cancelled, so we have x square minus x root 6 minus 1 divided by x square plus x root 6 minus 1, and c is the constant of integration. So now the required value of this integral I is given by I is equal to 1 over 2 root 6, and here this log may be written as ln. Here we can also write the base as e, and here we have x square minus x root 6 minus 1 divided by x square plus x root 6 minus 1, and c is the constant of integration, right? So this is the required value of this integral.